The subscription table though already has tenure defining. Using the Microsoft SQL function for subtracting dates, the definition is select date difference day comma start date case when stop underscore type is not null then else date as tenure. అక్కడి నుంచి tenure calculate చేసి 2006 నుంచి. Right. This expression follows the logic that a customer's tenure is known when the customer has already stopped. However, if the customer has not stopped, the tenure is as of the cutoff date. Okay. In order to have unbiased calculations for the hazard and survival probabilities, the start and stop dates need to be accurate. There are many things that can affect the accuracy of dates, particularly older dates. Customer records for stopped customers fail to be loaded into the database. The start date gets replaced with another date, such as the date the account was loaded into the database. The stop date gets overwritten with dates that occur after the stop date, such as the date an unpaid account was written off. The start date gets overwritten with another date, such as the date the customer switched to the another product. Right. Investigating dates is definitely important. The place to start is with a histogram of the starts and stops over time. The following query produces a histogram by year. Select year of the date as year. Some is start as starts. Some is stop as stops from. Select start underscore date as the date. 1 as is start. 0 as is stop from subsets. Union all. Select stop underscore date. 0 as is start. 1 as is stop from subs s. Group by year. The date order by 1. Okay, the results from this query is the table here is there. ఇది మనకు స్టార్ట్ టు స్టాప్లు అనేవి ఇలా ఉన్నాయి. ఓకే రైట్. Notice that there are over 2 million customers have the null stops. 2 million customers null stop dates. These customers are still active. వాళ్ళు ఇంకా still active ఉన్నట్టు. The first two rows of the table shows that there are 182 customers, okay, with questionable start dates, either null or in 1958. Yield 181 plus 1, 182 customers. Okay, the date for these customers is invalid. There should be no customer that predate the invention of the wireless phones. Because there are so few, the best thing to do is just filter them out. Alright, next. A very important feature of the date is that there are no stop prayer. Uh, there are no stop prayer to 2004. Was this because superior business practices during the time resulted in no stops? Probability not. Was this business the company forgot to record stop in the databases? Probably not. The most likely reason is that the data was loaded in 2004 and only active customers were loaded. This data is example of left truncation because rows have been filtered out based on the stop date. Then okay, in order to get unbiased estimates of the hazard and survival probabilities, the start and stop dates need to come from the same time period. For now, the solution is to filter the data, removing any starts that happened prior to 2004. In addition, one customers have negative tenure. So throughout this chapter, we will refer to the expression where start underscore date greater than 2004-11 and tenure is greater than 0 is part of the most of the queries the subscription table. 2009 start date. Next one is hazard probabilities. Hazard probabilities. Hazard probability at tenure T is the ratio between two numbers. The number of customers who come to the risk divided by everyone who could have stumbled to this. The demonstrator is called the population at risk at tenure T. The hazard probability is always between 0% and 100%. It is never a negative because the population at risk and the population that comes to the risk are counts and neither is ever negative. It is greater than 100% because the population risk always includes at least everyone who comes to the risk. The calculation is easy for any given tenure. We simply divide two numbers. Getting the right numbers is the challenge. As a simple example, consider 100 customers who start January 1st and active on January 31st. If two of these customers stop on February 1st, then 31st, 31 days hazard is 2%. If there are 100 customers in the population at risk and who comes, the ratio is 2%. అంటే పైన ఇచ్చిన టేబుల్ దగ్గర నుంచి ఎక్స్ప్లెయిన్ చేస్తున్నారు. ఇవన్నీ మనకు తెలిసిన టేబుల్ నుంచి మనం డేటా తీసుకోవచ్చు. ఇక నెక్స్ట్ మన ఇది ద విజువలైజింగ్ కస్టమర్స్ టైం వర్సెస్ టెన్యూర్. ఓకే, visualizing customers. Right. Right, visualizing customers time versus tenure. From this figure 3, this is the figure 3 there. Yes, this is the calendar time, that this is the cutoff date. So here customer 1, customer 2, customer 3, there are table, there are some points are there compared to the tenure. Okay, I want to explain these things. Okay, this figure shows two pictures of the same group of customers. In each picture, one customer is represented by a line with a vertical bar indicating where the customer starts and a circle indicating the stop date. అంటే ఎప్పుడు స్టార్ట్ అయ్యారు, ఎప్పుడు స్టాప్ అయ్యారు. ఇక్కడ స్టార్టింగ్ పాయింట్ ఒకటి పెట్టారు, లైన్ డ్రా చేసాము, సర్కిల్ ఒకటి రాశారు. ఆ సర్కిల్ దగ్గర వాళ్ళు స్టాప్ డేట్ అనమాట. స్టాప్ డేట్ కానీ లేదా కరెంట్ డేట్ కానీ. ఓకే, అండ్ ఓపెన్ సర్కిల్ మీన్స్ దట్ ద కస్టమర్ ఈజ్ స్టిల్ యాక్టివ్. అంటే ఇక్కడ మనకి ఈ సర్కిల్ ఓపెన్ సర్కిల్ అన్నాం కదా, ఇది మామూలు సర్క్యులేషన్ లోపల కలర్ వేయకుండా వాళ్ళు యాక్టివ్గా ఉన్నట్టు. సజెస్టింగ్ అన్ ఓపెన్ అకౌంట్. ఓకే, ఏ ఫిల్డ్ సర్కిల్ మీన్స్ ద కస్టమర్ హ్యాస్ స్టాప్డ్, సజెస్టింగ్ ఏ క్లోజ్డ్ అకౌంట్. అంటే ఇక్కడ ఏంటంటే ఈ కస్టమర్ క్లోజ్. ఓకే, ఇక్కడ కస్టమర్ ఏంటంటే మనం ఫీల్డ్ సర్కిల్ రాస్తే కనుక దాన్ని ఏమంటామంటే కస్టమర్ స్టాప్ అయింది అకౌంట్, ఇంకా రావటం లేదు అన్నట్లు అనమాట. రైట్, ద టూ చార్ట్స్ షో ద సేమ్ కస్టమర్స్ ఫ్రమ్ టూ డిఫరెంట్ పర్స్పెక్టివ్స్. ద టాప్ వన్ షోస్ ద కస్టమర్స్ బేస్డ్ ఆన్ వెన్ దే స్టార్ట్ అండ్ స్టాప్ ఇన్ calendar time. All customers that are active until the cutoff date. The bottom shows the same customers on the tenure timeline. Right. The customers have been shifted to the left, so they all start at the same time. Tenure is 0. On the calendar time, all the active customers were aligned on the right because they are all active on the cutoff date. Right. On the tenure chart, the active customers are interspread at all tenures. Some long tenure customers are no longer active and some are active. Some short tenure customers are active, some are not that much of active. The aside visualizing survival customers using Excel explains how these charts were made using Excel charts. Right. The calendar time frame and the tenure time both show customers and their tenures. Survival analysis focuses on the tenure time frame because tenure generally has the greater effect on customer retention. After all, the fact that customers can only stop after they have started puts a condition on the tenure but not on the calendar time. Also, a myriad of events happen on the tenure time frame, such as monthly bills, contract renewals, and the end of the initial promotion. However, the calendar time frame is also important. The calendar time frame has seen sensational and other things that affect all customers at the same time. One of the challenges in survival analysis is incorporating all the available information from these two time frames. Okay. Next one is the sensoring. The visualization of customers in the two time frames also hints at one of the most important concepts in survival analysis. The tenure of customers who have stopped is known because these customers have both a start date and stop date. అంటే ఇక్కడ మనకంటే వాళ్ళకి స్టార్ట్ డేటు, స్టాప్ డేటు 2 ఉంటాయి టైమ్ ఫ్రేమ్స్. ఎన్నాళ్ళు ఉన్నారు చెప్పొచ్చు కదా మనం జనరల్‌గా. హౌఎవర్ కస్టమర్స్ హూ ఆర్ స్టిల్ యాక్టివ్ హ్యావ్ యాన్ అన్‌నోన్ టెన్యూర్. అంటే మనకు ఆ టెన్యూర్ అన్‌నోన్ టెన్యూర్ అంటే ఇంకా ఆళ్ళు యాక్టివ్‌గా ఉంటే గనుక ఆళ్ళకి టెన్యూర్ అప్పుడే మనం క్యాలిక్యులేట్ చేయము. అన్‌నోన్ టెన్యూర్‌గా రాస్తాం. Right. Of course, their tenure is at least as long as they have been around, but the ultimate value is unknown. Any given active customers could stop tomorrow or 10 years from now. A tenure is an example of censored data values. This is the figure, right? Generally, the censored customers are represented by empty circles on the right hand. In this diagram, censoring is synonymous with being active, although this is not always the case. Okay, censoring can have other causes, as we will see in the next chapters also. A censored data values are central to survival analysis. There are three different types of censoring. AMTVA అంటే చూడండి. The type just described is strictly speaking right censoring. మనం చూసిన right censoring. This occurs when the tenure is known to be the greater than some value t. ఒక వాల్యూ టీ కన్నా ఎక్కువ టైం ఉండదాన్ని రైట్ సెన్సారింగ్ అంటాం. రైట్ సెన్సారింగ్ ఈజ్ ద మోస్ట్ కామన్ టైప్ ఆఫ్ సెన్సారింగ్. రైట్. నెక్స్ట్ నెక్స్ట్ వన్ ఈజ్ ద లెఫ్ట్ సెన్సారింగ్. This is the second type of censoring. Left censoring is the opposite of right censoring. This occurs when the tenure is known to be the less than some value t. టీ కన్నా ఎక్కువ రోజులు ఉన్నవాళ్ళు రైట్ సెన్సరింగ్ అంటారు. టీ కన్నా తక్కువ రోజులు ఉన్నవాళ్ళు లెఫ్ట్ సెన్సరింగ్ అంటారు. Left censoring is not very common, but it can occur when we have forgotten the start date of a customer, but we know it was after some date. Another example occurs when the data is a current snapshot of a group of customers, where there is a stop flag but not a stop date. So, a row in the data specifies that a customer has stopped. It also has the start date and the snapshot date. All we know is the customer stopped before the snapshot date only. Right. Interval censoring is the combination of left censoring and right censoring. It is basically the left censoring case when customers are still active. So they are right censored in addition to being left censored. Interval censoring can also occur when data is being collected at long intervals. For instance, researchers studying prisoners after they are released may check in on the prisoners every year. If a prisoner drops out of the study, the tenure is known only to the nearest year only. In customer databases, the start date is usually known. As an example of a situation where the start date is not unknown, consider the question of how long patients survive after cancer appears. The only date that is known as the diagnosis date of the cancer, not when the cancer first appeared. The age of the cancer is right censored because the start date is not known, but is known to be before the diagnosis date. Okay. Ironically, one result of relying on the detection date is that better cancer detection can result better 5 year survival after diagnosis, even for the same treatment. The cancer is simply diagnosed earlier, so the patient survives longer after the diagnosis. Left censoring and interval censoring are usually in the customer databases. The typical situation with customer databases is that the start date is known and the active customers are right censored. Survival and retention. Hazard probabilities measure the probability that someone comes to a risk at a given time. Survival is the probability that someone has not come to the risk up to that time. In other words, survival accumulates information about hazards. Point estimate for survival. Survival at a time t is the proportion of the customers who are active at a tenure t for a given tenure. The survival question is what proportion of customers survive to at least tenure t. ఓకే రైట్ దీనికి మనం క్వరీ ఎలా రాస్తాము అంటే సెలెక్ట్ 100 యాజ్ టెన్యూర్ కౌంట్ స్టార్ యాజ్ property risk some case when tenure less than 100 and stop type is not null then 1 else 0 and as scum to risk average case when tenure greater than 100 or time stop type is null. Okay, then 1.0 else 0 and as s underscore run from subsets uh, where start underscore date greater than some date and tenure greater than 0 and start underscore date less than date add like this. Okay, right. This calculation is similar to the point estimate for the hazard only. Right, calculating survival for all tenures. How to calculate the survival for all tenures? The customers who survive to tenure T are those customers that have not yet come to the risk of stopping. Mathematically, the survival at tenure T is the product of 1 minus the hazards for all tenures less than T. 1 minus the hazard is the probability that someone did not come to the risk at that point in time. It could also be called the incremental survival because it corresponds to the survival from tenure T to tenure T plus 1. Right, overall survival at a tenure T then is the product of the incremental survivals up to T only. This type of cumulative product is alas not readily stopped in standard SQL. Right, next. Fortunately, the combination of SQL and Excel makes the calculation easy. The first step is to calculate the hazards for all tenures, then to calculate the incremental survival, and then the cumulative product. The calculation of the hazard probability uses two items of information. First one, population that comes to the risk. The number of customers who stopped at exactly tenure T. Population at risk. The number of customers who tenure is greater than or equal to T only. Right. The population at a risk at a tenure T is an example of a cumulative sum because it is the sum of all customers whose tenure is greater than or equal to T. Excel is the tool to the choice of the calculations here. The calculation requires two values for the tenures. The number of customers whose tenure is exactly T and the number of customers that stopped at exactly tenure T1. Right. Select tenure count star as POPT. Some case when stop underscore type is not null that one else 0 end. As a stop T from subs where start underscore date greater than some date and 0. Group by tenure order by 1 only. When the results are copied into Excel, one column has tenure, one column POPT, and the third STOPT. Okay, if we move better. Assume that the results are copied with the data starting at the cell C29. Right. What is the population at risk at a given tenure? At a given tenure. The population at risk is the sum of the POPT values for the tenure and higher values. ఇది tenure క్యాలిక్యులేట్ చేయడం. ఓకే, రైట్. ఇది గ్రాఫికల్గా రిప్రజెంట్ చేశారు tenure. How to calculate the survival in SQL? Having the hazard and survival probabilities in SQL tables rather than in Excel is some convenient. Okay, one approach is to do calculations in Excel, save the result out as the text files, and the re-import them into SQL. Okay, however, it is possible to do the calculation directly in SQL in a multi-step approach. Suppose create the survival table with the appropriate columns. First and create the survival table with appropriate columns. Next, load the survival table with stop T and pop T. Okay, calculate the cumulative population and end tenure. Okay, calculate the hazard and num days. Next, calculate survival. Next, fix end tenure and num days in last row. This processing requires using SQL data manipulation language (DML), which includes insert and update. The syntax for these expressions varies more between databases than the syntax for the select. Also, when doing the processing, some steps are easier and much more efficient using database extensions, particularly those that allow cumulative sums. However, in this section, the calculations are here shown using self joins, an alternative approach supported by the standard SQL. Okay, how to do this one? Create a table, survivor, tenure అనేది integer type, POPT integer type, stop integer type, CMPOT integer type, hazard float type, survival float type, end tenure integer type, num days integer type. Most of these columns are similar to the Excel version. The purpose of the end tenure and num days is to take care of the situation where tenures are skipped because there are no active or stopped customers with exactly the tenure. The survival for a skipped tenure value is same as the survival for the previous tenure. The idea is that we can look up survival values using the expressions where tenure between survival, tenure and survival and a tenure. Okay, right. Right here, step 2. Load POPT and STOPT. ఓకే. ఇన్సర్ట్ ఇంటూ సర్వైవల్. మనకి అంటే లోడ్ చేయటం అంటే మన వాల్యూస్‌ని ఇన్సర్ట్ చేస్తాం. పైన టేబుల్‌ని క్రియేట్ చేసాం కదా! దానిలోకి. ఓకే. లోడ్ ఇంటూ సర్వైవర్. ఇన్సర్ట్ ఇంటూ సర్వైవర్. Select tenure. Count star as POPT. Some case when stop underscore type is not null, then 1, else 0. End as STOPT. Null as CUMPOPT. Null as hazard, null as survival, null as end tenure, null as num days. From subs where start underscore date greater than 2014 and tenure greater than 0, group by tenure. This is the same basic way you prepare the data for the Excel calculation. Here an insert statement is wrapped around the query to add rows into the survival. Step 3. Calculate cumulative populations. The next step is to calculate the cumulative population and end tenure. The self-join query that calculates these columns is select s1.tenure sum of s2.popt as CUMPOPT. Minimum of case when s2.tenure greater than s1.tenure, then s2.tenure minus 1 end as end tenure. From survival s1, left outer join survival s2 and s1.tenure less than s2.tenure group by s1.tenure. Right. The challenge is expressing this as an update statement. This is a challenge because this query is updating the same table that's generating the values. One solution that works for all databases is to place the results of the query in a temporary table and do the update from there. Another is to use syntax specific particular databases. Update survival, set survival dot CUMPOPT equal to SUMPOP. Okay, SUM dot CUMPOP dot survival end tenure sum. S dot S sum dot end tenure. Okay, right. From select S1 dot tenure, comma sum of S2 dot POPT as customer path. Mean case when S2 dot tenure greater than S1 dot tenure, then S2 dot tenure minus 1 and as an tenure. From survival S1, left outer join survival S2. On S1 dot tenure less than S2 dot tenure, group by S1 dot tenure. S sum where survival dot tenure equal to S sum dot tenure. Okay, right. Notice that this query uses a subquery with a self join within the update statement. Okay, some databases have extensions that make it is possible to calculate the cumulative sum more directly. For instance, Oracle's implementation of window functions. They support the syntax sum of POPT over order by tenure rows unbounded precedings. Okay, to do the calculations without a self joins. Okay, next one is the calculate the hazard. The next step to calculate the hazard probability and num days is update survival. Set survival dot hazard equal star STOPT into 1.0 by CEMPOPT, comma survival dot number of days equal to n tenure minus tenure plus 1. Calculate the survival. The survival calculation is another accumulation, but this time a product instead of a sum. Okay, what we are trying to do is to add survival as a column using logic such as the following. Select S1 dot tenure. Okay, call sec product 1 minus S2 dot hazard comma 1 as survival from survival S1 left outer join as survival S2 and S1 dot tenure greater than S2 dot tenure group by S1 dot tenure. The call sec statement takes care of the case when the tenure is 0. Right. In this case, there are no hazards, so the result would be null. The call sec returns the first non-null argument. Okay. Unfortunately, SQL does not support product function as an aggregation function. So we have to go back to high school algebra and remember how use logarithms. Raising e to the power of the sum of the logarithms of numbers is the same as multiplying the numbers together. The product is calculated like this. Select sum expect exponent of sum of log 1 minus s2 dot hazard. The logarithm is like exponent e power x etc. Okay, this expression sums the log of incremental survival and then undoes the log. A roundabout way to do the multiplication. One way to express the update in Microsoft SQL is using a correlated subquery. Update survival, set survival equal to case when tenure equal to 0 then 1, else select exp of sum of log of 1 minus hazard from survival s2, where s2 dot tenure less than survival dot tenure end. Right. This differs from the method used in Excel. Okay, in this query, survival is calculated as the products of all the previous incremental survivals rather than using a recursive calculations. The reason is that rows can be updated in any order. There is no guarantee that tenure 0 be updated before tenure 1. If a tenure 1 is updated first, it would get the value of null using a recursive approach because survival at tenure 0 is null before it is updated. Doing the full product calculates the correct value. Fix end tenure and num days in last row. The last row of the table has a null value for end tenure. If the following code fixes this one, update survival set end tenure equal to tenure plus 1 lakh minus 1 number of days equal to 1 lakh, where end date is null. Where end date is null only. Right. Extending the final survival for a long time makes it is possible to look up survival values in the table. even for tenures that go beyond the range of data. Ex- Extra generalizing the SQL, generalizing the SQL, right? Doing the survival calculations in SQL rather than Excel has an advantage because Excel's limit on the number of rows limits the number of tenures. This is particularly important when including grouping parameters such as market and rate plan and channels in the query. The combination of all these exceeds the capacity of an Excel. Modifying the preceding queries to support such groups is not difficult. First, the groups need to be included in the survival table, and step 2 needs to be modified to have the group by class. Then the queries in steps 3 and 5 need to be modified so that tenure comparison only occurs within the same group. For a single group, the syntax would like where survival dot tenure less than s2 dot tenure and survival dot group 1 equal to s2 dot group 1. This structure readily generalizes to any number of columns used to define the groups. However, as the number of groups grows, the size of each group decreases, meaning that there is less data for the survival calculations. Right. A simple customer retention calculations. Survival is one method of understanding how long customers stay around. Right. Customer retention is an alternative approach. The purpose is presenting it here is to better understand survival by comparing it to another sensible measures. A typical customer retention question is of customers who started triple X days ago, how many are still active? How many are still active? For that, we need to write the query. Select date difference, day, start date, comma 2006 12 28 as days underscore ago, count star as num start. Some case when stop underscore type is null, then 1 else 0 and as num actives. Average case when stop underscore type is null, then 1.0 else 0 and retention from subs, where start underscore date greater than equal to 2004 1 1 and tenure greater than 0. Group by date difference day comma start date 2006 28. Order by 1 only. Order by 1. Okay, this query counts the customers who started on a certain day, calculating the proportion that are still active. Right. The result has three columns of data. The first column is the number of days ago the customer started, relative to the cutoff date of the data. Other time units such as weeks or months might be more appropriate. The second column is the number of starts that occurred on that day, and the third column specifies how many of those customers are currently active. Okay, see the diagram. డేస్ వెళ్ళే కొద్ది రిటెన్షన్ రేషియో కూడా పడిపోతూ వెళ్ళిపోతుంది. ఓకేనా, డేస్ ఇంక్రీజ్ అవుతున్నాయి 0 నుంచి 450 వరకు. ఓకే, రిటెన్షన్ రేషియో 100% నుంచి 70 60 50 60% వరకు అలా డిక్రీజ్ అయిపోతూ వస్తుంది. రైట్. Like the survival curve, the retention curves always start at 100% because customers who just started are still active. Second, it generally declines. However, this decline can be jogged with the curve going up in some places rather than down. For instance, of customers who started 90 days ago, 80.1% are still active on the cutoff date. Okay, of customers who started 324 days ago, 80.4% are still active. Looked at in another way, this says that 19.19% of customers have stopped in the first 90 days, but only 19.6% of customers stopped in the first 324 days. Okay, this does not make sense. It is almost as if customers were re-incrementing between the 2 days. The practice it probably means that the particularly good customers were acquired 324 days ago and particularly bad customers were acquired 90 days ago. Right, comparison between retention and survival. Retention and survival. ఇది కంపేర్ చేస్తూ వెళ్ళే రిటెన్షన్ సర్వైవల్ ఆల్మోస్ట్ ఈక్వల్గానే ఉండే రిటెన్షన్. Right. Okay, both curves start at 100% and decline. However, the survival curve has no jaggedness because it is always flat or declining. Mathematically, this property is called the monotonically non-increasing. Okay, monotonically non-increasing, and it is always true for survival curves. Okay, survival curves are smooth; they do not exhibit the jaggedness of retention curves. Right, one way of eliminating the jaggedness on retention curves is to smooth the curve using moving averages. The problem is that the smoothness away useful information. Also, the points no longer have a clear meaning because they are averages of several different times, each of which has a different group of starts. A much better solution is to calculate the corresponding survival curve. Simple example of hazard and survival. Okay, this section explores the simplest example of survival, the constant hazard, in order to better understand the concepts underlying survival. Although such simplicity does not occur with customers, it does readily apply to a very different domain, a radioactivity. A radioactive isotype is one that decays at a constant time. At a constant rate. By emitting subatomic particles, it transmits into the other elements. The rate of decay is usually described in terms of the half of the time. Okay. Next, the customer hazard. A constant hazards are there. A constant hazard is exactly what its name suggests, a constant. Excel can handle all the calculations for a constant hazard. Right, next. Assuming a constant hazard, the half-life and hazard probability are interchangeable. If cell A1 contains the half-life, then the following formula in cell B1 translates this into a hazard probability 1 minus 0.5 power 1 by A1. Conversely, if B2 contains the hazard probability, then the following formula in cell C1 calculates the half-life minus 1 by log 1 minus B1 comma 2. Consider two radioactive isotopes of radium Ra-223 and Ra-224. The first has a half-life of 11.43 days and the second a half-life of 3.63 days, which correspond respectively to daily hazard probabilities of 5.9% and 17.4%. This means that after one day, about 95.1% of Ra-223 remains and about 82.6% of Ra-224 remains. The shape of the survival curve follows an exponential curve, which is always the case when the hazard is constant. These survival curve shows that within a few weeks, almost all the Ra-224 has disappeared. On the other hand, some of the Ra-223 remains because it decays more slowly. What happens to a mixer? What happens to a mixer? Right. Assume that a sample of radium contains 100 grams of Ra-223 and 100 grams of Ra-224. How does this mixer behaves? అంటే అది కింద చూపించా దాని మిక్సర్ బిహేవ్ ఎలా ఉండిద్దని దాన్ని అనాలిసిస్ చేస్తూ ఉంటారు రిపోర్ట్స్ ఎలా వచ్చినాయి ఏంటని చూస్తూ ఉంటారు అంతే. Right, constant hazard corresponding to survivals. Right, for each point on the survival curve, there is a constant hazard that would be produced the survival value at the tenure time. Okay, the probability of this, by using this formula, you can calculate the probability 1 minus b1 power 1 by a1. Okay, this is the one hazard probability diagram graph is there. Here, actual hazard is with thick line, constant hazard is somewhat light color line. Okay, this is the tenure of days, and this is the hazard probability. The actual hazard probability is very high in between 360 to 390, but the constant hazard probability is normal. Okay, it's like it's a line only, normal line, a little bit curve only. Okay, how to summarize the markets? Summarizing the markets. Okay, the subscriber data contains three different markets. Okay, Gotham, Metropolis, and Smallville. A good way to start the analysis is by looking at the proportion of customers in each market who are active as of the cutoff date. Okay, right, head of the date. చూడండి select market comma count star as customers, average tenure as average underscore tenure, some case when stop underscore type is null, then one else zero and as actives. Average case when stop underscore type is null, then 1.0 else zero and as active rate. Okay, from subs where start underscore date greater than this much, group by some market. There are two pieces of evidence in this table that suggest that Gotham is the worst market and small village the best in terms of customer retention. First, the average tenure of customers in Gotham is about 81 days, shorter than the average tenure of customers in Smallville. Second, of all the customers that ever started in Gotham since 2004, only about 46% are still active. Okay, right. How to satisfy the markets here? Okay, select tenure count star as pop t. Some case when stop underscore type is not null, then one else zero and as stop t from subs where start underscore days 2004 and tenure greater than zero and market Gotham group by tenure order by one only. Right, a better approach is to pivot the data so that columns contain the information about each market. Okay, right here select the tenure, some case when market equal Gotham, then one else zero, and as PUBG. Some case when market equal to Metropolis, then one else zero as PUBM. Okay, this is the some cases are there. Some of the cases like that only you can write down. Okay, the formulas have some minor differences from the earlier survival calculation. The formula for cumulative population is POPT plus the cumulative population at the next tenure. The hazard calculation takes into account the possibility that the population is zero. In this case, it returns the value NA because NA works best in chart. The survival calculation refers to the tenure column with a column fixed reference. Okay, instead of this one. Okay, this makes it easier to copy the formula across multiple columns. The column headers include the population in parentheses. Okay, the resulting survival curves in figure. Notice that the legend has the population in parentheses after the market name. The population was appended into the market name for just this reason. Okay, these curves confirm the earlier observation that survival in Gotham seems worse than survival in the other two markets. All three markets show the drop in survival at 1 year, which corresponds to the contract expiration date. At 450 days, safely after the contract expiration, only 50.1% of Gotham's customers remain, compared to 59% Metropolis for Smallville. Okay, coming to the survival ratio. Next one is the survival ratio only. Okay, right. The ratio between survival curves is a good way of comparing different groups because it captures long-term trends in survival. This ratio is simply dividing the survival for one market by the survival for another market. Let's use the best survival as the standard, which is small village. Right. Small village survival ratio is uninteresting because it is always one only. Right, coming. The survival ratio chart shows that Gautam's survival is uniformly worse than survival at all points in time. Okay, survival in Metropolis is as bad as Gotham's in the first year, but then it improves. Although the chart does not specify what is happening, the timing is suggestive. For instance, some customers start with 1 year contracts, some with 2 year contracts, and some with no contracts at all. Further, customers on 1 year contract are more likely to cancel at 1 year than during the first year. So perhaps the difference between Metropolis and Gotham is due to the proportion of customers on 1 year contracts. Okay, whatever the cause, the survival ratio changes for different tenures. There is not a uniform proportionality between the curves. Sometimes the ratio between survival curves can provide somewhat misleading results. For instance, if one market has very poor coverage in outlying areas, then customers from these areas would sign up for the service and quickly stop. Their cell phone is not working. A conditional survival. The survival ratio suggests another question about survival. Two markets have essentially the same survival characteristics for the first year, but then their survival diverges after the contract expiration period. What about customers who make it beyond the contract expiration? Do customers start to look up some similar differences? The conditional survival answers that. What is the survival of customers given that they have survived a certain amount of time? Right. Contract expiration typically occurs after 1 year. However, some customers procrastinate, so a period a bit longer than 1 year is useful, such as 13 months. Okay, here 13 months you need to write down where tenure greater than 319. Yeah, this approach requires recalculating all the survival values only. Okay, there is a simpler approach is there for tenure less than 3000, the conditional survival is 100%. Okay, for tenure greater than 390, the conditional survival is survival at the time t divided by the survival at 390. Okay. Comparing survival over time. There are 3 years of complete starts in the subscription data. The analysis so far have mixed all the data together. One interesting question is whether the hazards have changed over time. Okay, maybe changed over time also. Okay, like this. Right. The next here, how has a particular hazard changed over time? The calculation of a hazard is really the average of a particular hazard probability during a period of time. So far, this average has been over the 3 years of data starting in 2004. A trends in hazards, particularly in hazards relevant to the business, can provide important information. Okay, there is one graph is there. This graph is provides the month-wise calculations hazard at tenure 365 days. For this, you can write the query like this only. Select count star as path 365. Some case when stop underscore date equal to then 14, then 1 else 0 and as a 365. Average case when stop date is equal to then 6 to 14, then 1 else 0 and as H365 from subs where start underscore date greater than 2411 and tenure greater than 0 and stop underscore date 2006 to 14 or stop date is null and date difference dd start underscore date 2006 for 365. Okay, right, this is the one query is there. Select date 365 count star as path 365. Sum of case when stop underscore date equal date 365 and stop type is not null, then 1 else 0 and as stop 365. Average case when stop date equal date 365 and stop type is not null, then 1.0 else 0 as hits 365. From select s dot star date add dd 365 star date as the from substates. Okay, when start and store date 2014 1 కన్నా పెద్దగా ఉండాలి అండ్ టెన్యూ 365 కన్నా ఎక్కువ ఉండాలి. ఆర్డర్ బై డేట్ 365, ఆర్డర్ బై 1 ఓన్లీ. ఓకే, వాట్ ఈస్ కస్టమర్ సర్వైవల్ బై ఇయర్ ఆఫ్ స్టార్ట్? Okay, filtering customers by their start date is an acceptable way of calculating hazards. That is, filters by start date do not bias the hazard estimate. So, calculating hazards by year of start is similar to calculating hazards by market. The only difference is that the groups are based on year of the start date only. Okay, select tenure. Sum is 2004 as B 2004. Sum is 2005 as B 2005. Sum is 2006 as B 2006. Sum is 2004 into is stop as S 2004. S and start line. Sum is 2005 into is stop as S 2005. Sum is 2006 into is stop as 2006. From select S dot star case 1 year start date is equal to 2004, that 1 else 0 as is 2004. Case 1 year start underscore date is equal to 2005, that 1 else 0 and as is 2005. Case 1 year start date equal to 2006, then 1 else 0 and as is 2006. Case 1 stop type is not null, then 1 else 0 and as is stop from subsets. Okay, what did survival look like in the past? Right, important measure derived from survival. Survival and hazard curves provide nice pictures of customer over time and make it possible to compare different groups of customers visually. Graphics are great for conveying information, but survival analysis can also provide informative metrics. This section discusses that particular things also. At the point estimates of survival, the median customer lifetime and the average remaining customer lifetime. It ends with a discussion of confidence in the hazard values. Right. Next one is the point estimate of survival here. The point estimate of survival is the survival value at a particular tenure. For instance, earlier the point at 450 days was used to compare survival in the three markets. This calculation looks up the survival value at a particular point tenure value. The point estimate answers the simple question: how many customers do we expect to survive up to a given point in time? Okay, there are some situations where the point estimate is the best measure to use. For instance, many companies invest in customers acquisition. This is the true. Median customer tenure. Another measure of survival is the median customer tenure or customer half life. This is the tenure where exactly half the customers have left. The median customer tenure is easily to calculate. It is simply the place where the survival curve crosses the horizontal 50% line. The median customer tenure suffers from the same problem that all medians do. It tells us about exactly one customer, the one in the middle. Consider three different scenarios. Scenario 1: all customers survive for exactly 1 year and then all customers stops. Scenario 2: customers stop at a uniform pace for the first 2 years, so half customers have left after 1 year and the remaining half in the second year only. Okay, next scenario 3: half the customers minus one stop on the first day and the remaining are next day. All of these scenarios have exactly the same median customer tenure 1 year, because that is when half of the customer have left. Next, average customer lifetime అండి. The median customer lifetime provides information about exactly one customer, the one in the middle. Averages are more useful because they can be included in financial calculations. So if a customer generates 2000 in revenue per year and the average customer stays for 2 years, then the average customer generates $400 in revenue. The average truncated tenure is the average tenure for a given period of time after customer start. Answering a question such as what is the average number of days that customers are expected to survive in the first year. On the business side, it means that the results can validate after 1 year. On the technical side, average truncated tenures are easier to calculate because they are for a finite time period. Right. Calculating the average truncated tenure from the survival curve turns out to be quite easy. Next one is the confidence in hazards. An important question about the hazards is the confidence in how accurate they are. The way a statistician would pose the question is something like how close are observed hazard probabilities to the true hazards in the populations. Okay, for this you can write the query, select the tenure, some case when start and score date, then one else zero, like that only. Okay, tomorrow we will discuss about these things.